Hello everyone. In this video, I'll discuss about a new chapter called alternating currents, and we'll discuss about average value and RMS value of AC currents and some of their applications. Alternating current or alternating voltage we can define like this. Currents are voltages that periodically changes with respect to time. Currents are voltages. Currents are voltages which periodically changes with respect to time. Are called alternating currents or alternating voltages. Best examples will be like this. It can be a square wave. Suppose you are given a square wave like this, and it can be a triangular wave, and it can be a sawtooth wave, and it can be a sine wave. And most commonly used alternating current, it will be sine wave. So on y-axis, we will take either voltage or current. On x-axis, we will take time, and this value we'll call that as peak value, and the corresponding current or voltage we can represent like this: E is equal to E naught sine omega t, or I is equal to I naught sine omega t. Here E naught or I naught we'll call them as peak value or maximum value, and omega is angular frequency. Here this omega we'll call that as angular frequency. Omega is equal to 2 pi by t, where t is time taken to complete the oscillation, where t is time period, or omega is angular frequency. And omega we can write like this also: 2 pi f, where f is known as linear frequency. For a common household supply, its value is 50 hertz. So these two equations are very important, and we'll call these two values, this E or I, we'll call them as instantaneous value. Instantaneous values of current or voltage. So once we know instantaneous value, you can expect some questions to find average value or RMS value. So average value of AC, average value of AC. So if suppose we are having a sinusoidal wave like this, and E is given as E naught sine omega t, and if suppose they asked for complete cycle, complete cycle means from 0 to t, from 0 to t. So now the formula for average value, E average is given as integration of E dt by integration of dt. This is our general formula. We have to remember this. So now in that we have to substitute this. E is equal to E naught sine omega t. So E average value will be equal to integration of 0 to t E naught sine omega t dt by integration of 0 to t dt, or this denominator becomes 1 by t, and E naught I can bring outside, and integration of sine omega t, it will be minus cos omega t by omega. So we can write like this will be minus E naught by t omega cos omega is nothing but 2 pi by t into t. So, so tt gets cancelled. Cos 360 it is 0, cos 0 also 0. So that E average over a complete cycle is 0. The same is true even for average value of AC over a complete cycle is 0 for currents also. Why this happens means, just look at this note point I'll give you here. So if we are having a graph between current and time, area under the graph represents charge. So above x-axis we have to take that as positive, below x-axis we have to take that as negative, so that this will be a positive, net charge will be positive here and net charge will be negative here. So that total charge flown, total charge delta Q will be equal to 0. So I average will be equal to delta Q by delta T, it will be 0. So we can remember like this also, over a complete cycle, average current is 0. And similarly, if it is asked for half cycle, for half cycle means it is from 0 to t by 2. So for that, E is equal to E naught sine omega t is there. So E average value, it will be equal to integration of 0 to t by 2 E naught sine omega t dt by integration of 0 to t by 2 dt. So in the denominator we will get t by 2. So it becomes 2 by t E naught integration of 0 to t by 2 sine omega t dt, or this will be equal to 2 E naught by t. It will be minus cos omega t by omega within the limits 0 to t by 2, so that it will be 2 E naught by t into 1 by omega is nothing but 2 pi by t. As minus sign is there, first I will substitute lower limit, minus upper limit will be 2 pi by t into t by 2. So t gets cancelled, 2 also gets cancelled, cos pi is minus 1, cos 0 is 1. Here also I can cancel 2, t gets cancelled, we'll have E naught by pi into 1 minus of minus 1. This will be equal to 2 E naught by pi. This is average value over half cycle. And similarly, if they asked for average value of current over half cycle, it will be 2 I naught by pi. So here you can expect some simple question like this. Just look at this example. For half cycle from 0 to t by 2, means from here to here, they'll ask you The amount of charge flown in half cycle. Amount of charge flown in half cycle. In that case, as we are having I average is equal to total charge flown by total time taken. So that delta Q will be equal to I average into delta T. I average is 2 I naught by pi into delta T is nothing but T by 2. So 2 gets cancelled. It will be T into I naught by pi. So that is about amount of charge flown in half cycle. And one more interesting note point is here. For all half cycles, this value is not true. If suppose you are given like this, just look at this note point. If they asked for average value for a half cycle, that is from T by 4 to 3T by 4. Then whatever area here it is there, a same area will observe here. So in that case, net charge will be 0 and hence I average value will also be equal to here 0. Only for 0 to T by 2, we will get a value of 2 I naught by pi or 2 E naught by pi. And after average value, we'll have RMS value or root mean square value of AC. Root mean square value of AC, or we'll call that as RMS value. And the general formula will be like this. IRMS will be equal to integration of I square dt by integration of dt under root will be there. So generally this is our formula, but we'll write like this. IRMS square will be equal to integration of I square dt by integration of dt. So at the end, after solving that integration, at the end, we can take that square root. This is another interesting equation, very important equation. Just look at this. For the same sine wave, what is RMS value for half cycle? If they ask like this, or for a complete cycle, I is equal to, we are having I naught sine omega t. So I RMS square will be equal to integration of 0 to t. I square means I naught square sine square omega t by integration of 0 to t dt. So here in the denominator we will have 1 by t. I naught square we can bring outside. Integration of 0 to t sine square omega t dt. So now from this we can write sine square omega t as 1 minus cos 2 omega t by 2. So if I substitute that our value here, we'll have I naught square by 2t into integration of 0 to t 1 minus cos 2 omega t dt, or from this I naught square by 2t integration of 0 to t dt minus integration of 0 to t cos 2 omega t dt. And just in the previous example or in the previous application, we observed that integration of cos function over a complete cycle it is 0. So that now it will be I naught square by 2t integration of dt is t within the limits 0 to t. So that it will be I naught square by 2. This is I RMS square value, or from this what is I RMS means it will be I naught by root 2, or it will be 0.707 of I naught. So you can expect some questions based on this. RMS current is very, very important. And it is true for half cycle or complete cycle. If they ask for RMS voltage, it will be E naught by root 2. Is it clear? So here I want to mention one note point which is helpful for our further examples or applications. Integration of 0 to t, it can be sine omega t dt, or integration of 0 to t cos omega t dt, they will be equal to 0. And similarly, integration of 0 to t sine square omega t dt, or integration of 0 to t cos square omega t dt, their value will be equal to t by 2. Just remember these two identities from mathematics so that which will be helpful for you while solving some numericals. Now we'll go with some examples based on this I average and I RMS. Just look at first example. Find time taken for the current to reach peak value or else to reach RMS value. They may ask you this kind of questions. So as we are having I is equal to I naught sine omega t. So they're asking about I has to become I naught, that is equal to I naught sine omega t. So I naught gets cancelled. So we'll have sine omega t is equal to 1. This is possible only when omega t is equal to 90 degrees, which is pi by 2, or t is equal to pi by 2 omega, or else pi by 2 into omega is nothing but 2 pi by t, or that will be equal to t by 4. They may ask in terms of omega, or they may ask in terms of time period. That's why I derived both. In a similar way, we can solve for in what time it will reach RMS value. So for this, from the same equation, I is equal to I naught sine omega t. Now I value is I naught by root 2, that is equal to I naught sine omega t. So I naught gets cancelled. So from this, sine omega t is equal to 1 by root 2, or omega t is equal to pi by 4, or from this t is equal to pi by 4 omega, or else we can write like this pi by 4 into 2 pi by t, or that will be equal to t by 8 seconds. So this kind of questions you can expect in what time the current will reaches to a peak value or the current will reaches to a maximum value, so that you can solve like this. And now look at this next example. If you are given find I average or I RMS for a current for I is equal to, if it is given like this, I1 plus I2 sine omega t. In that situation, what is our I average formula? I average over a complete cycle. They'll ask you like this. So I am taking over complete cycle. So I average, formula for I average is equal to integration of 0 to t I dt by integration of 0 to t dt. So in the denominator we will get 1 by t. So integration of 0 to t I1 plus I2 sine omega t dt, or from this 1 by t integration of 0 to t I1 dt plus I2 I can take out common integration of 0 to t sine omega t dt. So that over a complete cycle, sine function becomes 0. As we know that I can take this value to 0. So we left with 1 by t. I1 we can bring outside. Integration of dt is t. So t gets cancelled. So I average will be equal to I1. That means if suppose you are having one question like this, if you are given I is equal to 2 plus 3 cos omega t, and they are asking what is I average for this current. I average will be equal to 2 only, 2 amperes. This kind of questions you can expect here. This is about average value of current for that. If suppose they ask RMS value, we are having I RMS square is equal to integration of 0 to t I square dt by integration of 0 to t dt. So 1 by t I can write outside because integration of dt is t and that limit will come outside. I square we can write like this, I1 square plus I2 square sine square omega t plus 2 I1 I2 sine omega t dt over an integration of 0 to t. So that 1 by t integration of 0 to t I1 square dt plus integration of 0 to t I2 square sine square omega t dt plus 2 I1 I2 integration of 0 to t sine omega t dt. And over complete cycle this is 0. So now we are having only two functions. In that 1 by t we can bring I1 square outside. Integration of dt will be t. So that limits are 0 to t plus I2 square integration of 0 to t sine square omega t, it will be t by 2. I gave that note point, just refer that note point. So from this we can take the t as common, the t gets cancelled. We left with I1 square plus I2 square by 2. This is I RMS square value. So I RMS will be equal to under root I1 square plus I2 square by 2. So the same example I'll quote here again. If suppose they gave like this 2 plus 3 cos omega t or 2 plus 3 sin omega t, then I1 is 2 and I2 is 3. So I RMS value will be equal to square root of 2 square means 4, 3 square is 9 by 2. So that this will be equal to square root of 17 by 2. This kind of questions you can expect. By giving an equation they may ask, and they may ask you by giving one more kind of equations like this. Just look at this example. As these are alternating currents, there might be some phase difference between two different currents. By giving two different currents, they may ask you what is resultant current. Just look at this. If suppose you are given like this, there are two currents. I1 is equal to, or I is equal to, I is equal to I1 sine omega t plus I2 cos omega t. They'll ask you to find I average or I RMS. In that case, we can write the same equation like this. I1 sine omega t plus I2 sine omega t plus pi by 2. Then we can use our parallelogram law of vectors. Here there are two amplitudes, I1 and I2 are two amplitudes or peak values, and there is some phase difference between them. That phase difference is pi by 2. So that resultant peak value if I'll represent with I naught, it will be square root of I1 square plus I2 square plus 2I1 I2 cos phi or cos theta, and that resultant direction, if they ask, tan alpha will be equal to I2 sin phi by I1 plus I2 cos phi. All these equations we are writing from our parallelogram law of vectors. So now just look at this here, that phase difference is pi by 2. From that resultant value of the peak will be I1 square plus I2 square plus 0, or that will be simply square root of I1 square plus I2 square. So that if you know that value, then they may ask you about IRMS or I average. IRMS, if they ask, it will be I naught by root 2, that will be equal to square root of I1 square plus I2 square by 2. So you can expect some questions like this, though I am giving that example. In exam they may give with numericals. Suppose they gave 3 sine omega t plus 4 cos omega t. And they'll ask you what is IRMS. IRMS will be equal to simply square root of 3 square plus 4 square by 2, or this will be equal to square root of 9 plus 16 by 2, or it will be 5 by root 2. This kind of questions you can expect. So this is about, by giving some equation, they may ask you IRMS values or peak values, and after this they may ask you by giving some graph or equation. Just look at this example. If you are given, there is a square wave, so this is 0, this is t they gave, and this value is V naught, that voltage value, and this is time. They'll ask you find V average and VRMS. So if you are given any graph like this, then we have to develop that equation from 0 to t. V value is equal to V naught. Then what is our V average formula? Integration of 0 to t V dt by integration of 0 to t dt, or in the denominator we will get 1 by t, and V value is V naught, which is a constant. So integration of 0 to t dt, or this will be equal to 1 by t V naught into t. So t gets cancelled. V average value is equal to V naught. And similarly, if suppose they ask it for VRMS, VRMS square will be equal to integration of 0 to t V square dt by integration of 0 to t dt, and in the denominator we will get 1 by t. V square means V naught square, integration of 0 to t dt, so that this will be V naught square by t into t. So VRMS will be equal to V naught. So you can expect some questions like this. And here in this question, it was V average and VRMS both are equal to V naught. This is not true in all the cases. Just look at this one more example. If you are given a graph like this, this is T by 2, and this is a graph between voltage and time, and the peak value here it is V naught. So for that half cycle, they will ask you what is I average or V average or VRMS over half cycle, they may ask. In that case, there is no equation. We have to develop the equation. It is a straight line passing through origin. Slope of this equation, that will be change in y-axis by change in x-axis, will generally represent with m. That is equal to V naught by T by 2, or that will be equal to 2 V naught by T. So as it is straight line passing through the origin, so we can write an equation like this: y is equal to mx, y is v, and m is 2 v naught by t into x-axis, it is time. So now this is our general equation for that wave, for that half cycle. Then if they asked for v average value, that v average value will be 0 to t by 2 v dt by 0 to t by 2 dt. In the denominator, we can directly write t by 2, and integration of 0 to t by 2, v is 2 v naught by t into t. So here already 2 by t, 2 by t, I can write 2 by t whole square. V naught we can bring outside. Integration of 0 to t by 2 t dt. So now from this, this will be equal to 2 by t whole square v naught integration of t. It will be t square by 2 over a cycle 0 to t by 2. So v average value we can write like this. This will be 2 by t whole square into v naught by 2 into t by 2 whole square. These two gets cancelled. We'll have v average value as v naught by 2. Similarly, if they asked for v RMS value, we have to take square of this 2 v naught by t into t whole square. So v RMS, if they ask, it will be equal to in v RMS square integration of 0 to t by 2 v square dt by integration of 0 to t by 2 dt, or it will be 2 by t v square, as it is 2 v naught by t whole square. I can write 2 by t whole square v naught square outside integration of 0 to t by 2 t square dt, so that we are having 2 by t whole cube v naught square into t cube by 3 within the limits 0 to t by 2, or v RMS square we can write like this: 2 by t whole cube into v naught square by 3 into t by 2 whole cube. This t by 2 whole cube, 2 by t whole cube gets cancelled. So v RMS will be equal to v naught by root 3. So like this, you can find RMS values as well as average values or complete cycle if suppose they gave a graph based question. So that's it for this video. I hope this video is very helpful for finding I average and I RMS, or E average and E RMS for different given equations or graphs, or else general sign functions. Please subscribe and share Progressive Physics Learning Profile, which is helpful for both JEE mains as well as NEET students. Have a great time. Thank you.